All right, in this video, we're going to do a statistical analysis example using the calculator so we can go through all those steps. It seems reasonable that there would be a relationship between the amount of time a student spends studying and their GPA, or their grade point average. Suppose you were interested in predicting a student's GPA based on the hours they studied per week. You were able to randomly select 12 students and obtain this information from each student. All right, so we're looking at hours studied versus GPA. Our independent variable is going to be hours studied. Our dependent variable is going to be GPA, and I wrote R, GPA. What is the LSRL, least square regression line, prediction equation? So remember, those are all the same thing. So I'm going to grab my calculator, so you can see it, and I'm going to go to stat. So I'm going to hit the stat key right here, stat. It's going to bring up this menu, edit. So I'm going to hit enter. It's going to bring me my table, L1 and L2. Now, I've gone ahead in the interest of time and plugged in the hours, which we said was X, and the GPA, which was Y. So I've gone ahead and I've put in all those values, making sure they all line up. So at the end, I'm going to make sure I have my line up here. So 9 went with 45. That was my last table here. To calculate the least squares regression line, I'm going to hit stat again. And I'm going to move over to calculate. So we're going to calculate the linear regression. We're going to go down to option 4 where it says linear regression. I'm going to hit enter. I'm going to hit enter again. Your calculator, you might have to hit calculate. And it's going to give me my AX plus B, giving me my A and my B. So my equation is going to be Y equals 0.152 X plus 2.25. Interpret the slope and the intercept. So the slope here is 0.125. What that's going to tell us is the GPA will increase 0.152 points for every hour studied per week. The y-intercept is going to be the starting GPA if you do not study, or study 0 hours, however you prefer to say that. Create and interpret the residual plot. All right, so we're going to go back to our calculator. I have to calculate the residual plot. So I'm going to go back to my table, stat edit. I'm going to move over to L3. I'm going to go up to L3 to tell it to fill that column. And I'm going to hit the second and stat. So I'm selecting list. So second stat. I'm going to go down and select residual. Hit enter again. It's going to self-populate that third column. Now I'm going to go ahead and I'm going to look through these residuals. They tend to be kind of between -1 and 1, except for this one. So I want to include that. So maybe -1.5. All right. So I know I have to see those. So I'm going to go to my window. My X I can keep based on my X values in my table. My Y's I'm going to change to be -1.5 for my minimum and 1.5 for my maximum. Now I want the residual plot. So in our calculators, that's L1 and L3. We set our calculator up for the plot number 2 to show us those. So I'm going to go Y equals. I'm going to move up to my plots. I'm going to highlight plot 2 and hit enter so that is now highlighted. Then I'm going to hit graph. Now I have my residual plot. Looking at my residual plot, there is no pattern. Which tells us it is a good fit. A good fit model. Find the correlation coefficient R and interpret. So that was back in when we calculate our linear regression. So our R is 0.73. To interpret the R value, we're going to say the direction, so it's positive, and the strength, moderate. Remember that the correlation coefficient tells us direction and strength. It does not tell us if it's a good fit or bad fit. Only the residual plot tells us if it's a good fit or bad fit. All right, let's look at R squared. R squared can be found two ways. I can take the R value, 0.73, and square it. That gives me 50.5329. Or we found it on our calculator here, R squared. Now my R squared on my calculator is slightly different than my R squared here because I cut this decimal down. I rounded it. So either one that you want to use, they both are about 53%. So remember, R squared is a percentage. So 53%. To interpret, we're going to use our description. So we're going to say, and we're going to say 50, let me move the camera here. 53% of the variability now we're going to use the dependent variable, which was GPA. So GPA, I don't know why I keep writing R. GPA can be explained by the linear relationship with hours studied. Per week. So that is finding our R squared and interpreting that R squared. Remember, the whole sentence stays the same except we change the percentage, we change what the dependent variable is, and we change what the independent variable is. All right, we're going to look at a couple more questions here. First one says, if the furthest residual is negative 1.1, what are the equations for the bounds? So we're going to take the absolute value of that residual. So the absolute value of negative 1.1 equals 1.1. So that's the distance that we want to move. Okay, now we're going to write our upper and lower equations. So I'm going to remember, so this is going to be our lower, and we'll do our upper. They have the same slope as the equation line. So 0.152x. 0.152x. Now our intercept for that equation was 2.25. So for my lower boundary, I'm going to subtract 1.1 from 2.25. 2.25 minus 1.1 is going to give me positive 1.15. And then I'm going to add 1.1 to 2.25 for my upper, giving me 3.35. And these will be my boundary equations. What is the range of predictions for GPA if you study 8 hours? So we're going to put 8 hours into the lower and into the upper. So if I go ahead and put it into the lower equation, 0.152 times 8 plus 1.15. We get a lower bound of 2.366. And if I substitute into the upper, 0.152 times 8 plus 3.35, we get an upper of 4.566. So we would say our prediction should fall between those two values. A student who studied 13 hours scored a GPA of 2.6466. This is the actual data point that happened. What is the residual and interpret it? All right, so I'm looking for residual. Residual equals actual minus predicted. It tells us how far off the actual is from the prediction. I have the actual. I don't have the prediction. I got to find the prediction. So we're going to plug in 13 into our prediction equation. Not our boundary equations, but our original. So that was plus 2.25. 0.152 times 13 plus 2.25. This gives us a prediction of 4.226. So my residual will be 2.6466 minus 4.226. This gives me a residual of negative 1.57. 1.57. Would you want a positive or negative residual in this case? I would like my actual GPA to fall above, so I would like a positive residual because that would tell me my actual data point is above the predicted data point. So that is kind of how to use the calculator, going through kind of every piece we talked about for an example of data. Hope this helps.